The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next speaker is Chris Spall from Vector Corrosion Technologies. He's going to speak about vertical and overhead spall repair.
Thank you, David. This is ACI Repair Application Procedure, Bulletin 6, vertical and overhead spall repair by hand or trial application. And there you see the document itself. Okay, so what is the purpose of using this method for concrete repair? The primary purpose is to replace spalled or deteriorated concrete and improve the appearance of the structure and to provide protection to reinforcing steel in the repair area, as opposed to like the low velocity spray that you saw previously or other methods such as form and pump, form and pour, etc. The repairs on this type of method are generally less structural in nature and more of a surface repair or cosmetic is very common. So you see the picture on the right that would be an indication of the type of repair you might see. So as I said, when do you use this type of method? The repairs are commonly small, thin, or cosmetic in nature. It is a vertical and overhead repair method. So you're looking at using columns, beams, anything with a vertical or overhead orientation. If you do have larger repairs to complete and more structural in nature, this would probably not be the preferred method of repair. For one reason, it's be more labor intensive than some of the other methods. But the other methods can get better consolidation and more structural repair materials into the repair itself. So, for example, on the photographs on the right, you see that the method on the repair on the top may be a good application, but the repair on the bottom, where you see widespread repairs, this project was actually completed using a shotcrete method. So, some of the steps in the process. The first step is bulk concrete removal. So basically you're going to remove the loose concrete with a lightweight chipping hammer. Usually you'll refrain from using heavier hammers or jackhammers because we want to prepare the surface and remove the deteriorated concrete, but we really don't want to create any additional damage to the base structure by cracking or damaging it. So lighter weight hammers are typically involved. And plus, these are vertical and overhead in orientation anyway, so the lighter hammers are easier to handle. You want to have a rough surface for bonding the material. So it says here approximately 1/4 inch in amplitude for the surface. So you get, in addition to some type of chemical bond between the repair material and the surface, you also get a mechanical bond with the roughened surface. In some cases, you want to continue the bulk removal until you start to get into clean steel. If this is a corrosion-related repair, that would be a preferred method, is to expand the area of the repair outside of active corrosion, or in some cases, the engineers will limit the area of the repair by marking out the deteriorated method only. And there you see the bulk concrete removal in process. A very important part of the process is the edge and surface, or the edge conditioning and cleaning. So after you remove the bulk concrete, the next step is to ensure that your repair themselves are square or rectangular in shape. and that way that you are basically avoiding irregular shapes, which may lead to unusual cracking patterns in the material. So square or rectangular shapes are preferred. Most of the materials in this type of repair, you also want to saw cut a small edge around the perimeter of the repair. So that's to prevent what we call feather edging, or having a very thin layer of material on the edge of the repair, which will be not as strong or as durable as the bulk of the repair itself. So it obviously will depend on the material that is selected, but generally it's going to be somewhere around 1/2 inch saw cut around the edge, and that would be perpendicular from the surface into the repair. So you see on the bottom left, you see the prepared patch with the saw cut edges. All right. So after you've removed the bulk concrete and you've saw cut your edges and you've ensured that you have a good shape of the repair itself, probably one of the most important steps is to make sure that you have a good prepared surface for the materials to bond to. And the steps here would be to basically abrasive blast or high pressure or moderate pressure water blast the concrete itself. And you want to make sure that that any dust or contaminants or damaged fractured concrete pieces that you might not see visually are removed by preferably abrasive blast cleaning the surface. So that's going to remove some small microfractures on the concrete, give you very open pores in the concrete substrate in order for the material to bond well. During that process, you also remove the rust and any cement paste that's residual on the reinforcing bar itself. You may also use abrasive blasting or wire wheels as well. That's a very important step because as we're doing the repairs, in many cases the repairs are caused by corrosion, from chloride contaminated concrete. And we want to make sure we want to remove the cement paste with any residual chlorides so that the bars are clean and that the material can bond well to the bar as well. And then finally, most common, you're going to use a saturated surface dry condition for the concrete. So you've cleaned it, you've opened the pores. You're going to wet the concrete, the base concrete, to the point where it's wet or saturated, but not glistening on the surface, where the surface is somewhat dry. And because many of these repairs are thin repairs, you don't want to have a lot of moisture from the repair material being sucked into the base concrete, which would dry out the material and affect its durability. So saturated surface dry condition is typical, but refer to the manufacturer's data sheets. And just as a reference, ICRI, one of the first guidelines that the International Concrete Repair Institute developed with regard to repair is the Guide for Surface Preparation for Repair of Deteriorated Concrete Resulting from Reinforcing Steel Corrosion. I believe that number has been updated to R310-.1, I believe. But it's a very good reference for the methods for preparation. Okay, so you've prepared your surface. Now you're going to proceed to install your repair material. So the equipment and the equipment materials and equipment selection. Obviously, since this is a vertical and overhead repair, you want to have materials that have non-sag properties. And most of these are pre-bagged materials from many of the manufacturers involved in our industries. In addition to the non-sagging characteristics, there's a whole list of properties that could be specified by the consulting engineers, anywhere from different types of set times to important properties such as shrinkage of the material, freeze-thaw resistance, etc. So those properties should be specified by the consulting engineer or the owner. Mixing the material, since these are typically small repairs, it's very common to use to mix one bag quantities at a time. So you're going to be generally using a pail with a drill and a paddle mixer If you do have a lot more quantity of repair to complete, you can use small mortar mixers as well. So obviously you're going to measure the water, so you need some containers for measuring water. Then the other materials such as air compressors, saw cutting equipment, abrasive blasting, and your trowels and other finishing tools are important to complete the repair. As always, safety is very important. These materials that you're going to be using are very alkaline in nature, cement-based. So you want to make sure you review the material safety data sheets, make sure they're available on the job site in an accessible location to all the workers. Protective equipment, PPE, gloves, clothing, eye protection, dust mask, it says forced air respirators. That would be more likely used when you're doing your abrasive blasting operation. Hearing protection, your chipping hammers. You need to provide some hearing protection. Obviously, you want to make sure your equipment's in working order and refer to the current OSHA standards. And then finally, you get to the point where you're going to install the material. So you want to make sure that you're placing the mixed repair material with sufficient pressure to get good intimate contact with the saturated surface dry substrate. So you're going to be essentially pressing the material very firmly into the surface. Many times the manufacturers will recommend scrubbing a small layer very firmly into the base and then coming with the bulk mix after that. Pay particular attention to consolidation of material around corners and around the reinforcing steel. And if the repair depth exceeds the limitations of the thickness of the material that can be achieved in one lift, you may need to do multiple lifts of material. So in that case, you'll do the initial lift. You'll roughen the first lift of material to provide a roughened surface for the subsequent lift to bond to achieve your final thickness. Then you're going to strike off and finish with trowels or floats. And then one step which is commonly omitted but is very important is the curing process. You know, all these materials are Portland cement-based materials, so they need to be cured according to the manufacturer's instructions. Moist cure or curing compounds are commonly used. Once the repair is completed, how do you check the repair to ensure that it's been completed appropriately? You saw the previous presentation talk about photographs before and after. That can be used. Obviously, just the observation and documentation of the surface profile and cleanliness. Basically, you can sound the repair itself to make sure that there are no hollow spots, and ensure that it's well consolidated and there's no delaminations in the repair. Bond testing is also possible. There are guidelines to basically do pull-off testing where you're coring into the material, slightly into the base concrete, and pulling off and determining the bond strength, but also where the failure mechanism is. Did the bond exceed the tensile strength of the concrete is one of the criterias. This type of testing would be commonly done by an independent materials laboratory. And that's repair application procedure number 6, vertical and overhead repair. Yes, sir.
Chris, when you're building up these lifts and you're roughening, in your opinion, what's the best tool for creating that roughened surface?
What's the best tool? Very common, you're using the edge of a trowel. That creates kind of thin layers. It may not be the best, but I would say that anything that's going to create a more similar profile to your base concrete would be better than just the edge of a trowel. If you're just making hatch marks, you're going to get roughened surfaces in isolated areas and not over the entire first lift of the repair.
Thank you very much.